All right. Well, welcome everybody once again to Astronomy Daily live streaming for the next hour-ish or so, talking about all things astronomical, just turning off the TV, forgetting about the news, and just talking astronomical things for a little while, just amongst friends, sharing a passion about, the universe. And as I always say, I'm sort of standing on three legs, right? I've got curiosity, I've got skepticism, and I've got um, open-mindedness. And those three things really uh, keep the doors wide open in terms of thinking about this kind of stuff um, and not getting bogged down in any kind of beliefs or anything like that. It's like, let's do this exploring, but don't get stuck, right? I mean, I think a lot of scientists and a lot of astronomers are sort of stuck these days. And, it's not as if this kind of thing hasn't happened lots and lots and lots of times in the past, right? Where, we sort of get this idea that, okay, we're pretty sure, right? This is how things are, and we're not really going to listen or look or talk about anything else because everything else is just sort of, crazy and woo woo and no, so these weird ideas about the sun being the center of the solar system. Oh, no, 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 no. All of our data says that the Earth is in the center, and we can show you the data. Right, here's the data, and I pull up that example lots and lots and lots of times, but there's lots of examples of that, and even today, right? I mean, you must agree that there's a lot of confusion and there's a lot of surprises and there's a lot of scratching of heads about things, and it's like, oh wow, that doesn't match what we think it should be. And I see that as an opportunity. It's like, well, let's use the tools that we have at hand and um, go after these things. So yeah, that's part of what this live stream is about. Is sort of using the tools of science to dive into all kinds of things, right? And not preach the dogma. Um, Talk about what we currently think, but realize that we're either completely wrong about that, or we don't have the whole picture. And if we think that we have the whole picture, that throws up the skepticism red flag with me, and I'm like, oh really? So yeah, probably not. If we're so sure, yeah, we probably boxed ourselves into a corner, and need to get out somehow. So yeah, so I'm seeing Tom in the chat, Atta's in the chat, Uncle Bill's in the chat, and yeah, Parallax Nick. I'm gonna check out some of his other videos too, because those are really well produced. A little formal, but that's okay. I have no problem with that at all. I mean, obviously, he's written out a script, and and that, but there's nothing wrong with that, nothing at all. So yeah, I watched, and I think I posted a link to a video that he just posted about the rings of Uranus and Neptune, and yeah, I had absolutely no idea, that Herschel, right, back in the 1700s, might have actually seen Uranus's rings, and as a good scientist, right? It's like you make an observation, and it's like, okay, well, I'm thinking that I'm seeing this, right? And then you look and you look and you look, you try to gather more data. And after a while, he's sort of like, well, maybe I didn't see that, right? I mean, he didn't really have any means of recording that. I mean, I guess, if he had any kind of drawings or anything, I mean, that's sort of a record. But even a drawing or a photograph, you know, at, if you see something once, right, and then you never, ever, ever see it again, it's sort of like, you know, over time, it's sort of like, well, did I see that? Did I actually record that? And sort of in the modern era, right, we could make some kind of digital recording of it, or some kind of a photograph, and it's like, well, there it is, there it is, there it is. Never seen it again, but there it is. And yeah, uh, I didn't realize that Herschel had actually, maybe actually seen Uranus's rings or Neptune's rings, I forget which. Um, and you know, After a while, he's sort of like, well, don't see them, don't see them, don't see them. Well, maybe I didn't see them. so, maybe a bit too much wine that night or something. Who knows, right? So, yeah. Anyway, I really do like Parallax Nick's videos, and I will definitely be checking more of his out, because they are intelligent. They're really well produced, and yeah, so definitely check him out. He's doing the right thing, and looks like he's got a lot of subscribers, lots of views and everything. So yeah, he is doing it right, and yeah, when I find those kinds of things, I'm definitely going to post them here, because yeah, that's the kind of stuff that I want to see too. So cheers to Parallax Nick. I've got the hydrogen hydroxide again tonight. So cheers. And also in the panel again is Bobby. Hey there, Bobby. What's going on?
Nothing much. Except I think we got some bad conditions with the solar wind hitting the Earth and causing a lot of storm with radio propagation.
So, I mean, this is both a good thing and a bad thing, right? I mean, for radio listeners, that's usually a good thing, right? When you have a lot of activity, is that true?
Well, when you have solar wind hitting the geomag, it could be bad for radio.
Okay, all right, yeah. We don't.
We was at the K index at 706, and we
Wow,
got a G3 geomagnetic storm.
wow. Is that a coronal hole, or is there some kind of
Yeah,
CME?
like a CME. I think it's like a CME. I don't know. I forgot.
Probably a coronal hole. We can actually let's go over and take a look. We can actually look at the sun. Let's do that really, really quick. We can sort of see. I mean, it's probably a coronal hole. I haven't heard any.
Yeah, your best bet is go to solarham.net and look at the headlines.
Okay, cool. I we can do that, and let's also just go over to SDO too.
Yeah, right now the K is at 3 now, so it should be coming down anytime soon.
Yeah, that's starting to drop. Okay, well, I'm not seeing any. I'm not seeing any major coronal holes, so I'm sort of wondering if this active region over here. Are you guys seeing that? Okay. Um, um, yeah, I'm sort of wondering if this active region here maybe might have pumped out some kind of a CME, because usually if you have an equatorial object, right, and it passes right about here, this is the connection to the Earth, is right about here, because it takes a few days for that stuff to blow to the Earth. Usually a few days, couple days. So usually when it gets to around here or so, that's when it's going to connect with the Earth. Let's see. Can we? Where is? Can we make movies with this? Daily movies. Maybe I'm looking at the daily movie directory. Let's look at that. Oh, well, let's see. 2018 8. This probably isn't where I want to go with this, but we'll go with it anyway. MP4. Let's see what this does. Maybe it'll give me some joy, maybe not. Okay, so that's just the visible. Yeah, that's not going to give me any joy. Let's go over to Soho instead. Maybe that's the. I want to look at CMEs if there were any. Best way to see a CME is with the LASCO instrument here, and let's see, we can make a GIF movie out of it, I think. So we'll let this load. You can see the date and the time here, and let's see if we get a blow here, a CME event. Should be, if it's happening now, if we're getting some kind of a event now, it would have blown a couple days ago. So let's see, and there is definitely an active region where there's some sunspots. So let's see if they did anything here. I'm not seeing anything yet. Not seeing anything yet. And then we'll go over to that other site too, Bobby, that you mentioned. I definitely like to check all these things out. But, not seeing any CMEs.
Yeah.
I would expect it with a K index of 6 or 7 that, wow, that sounds like a CME event. But I'm certainly not seeing anything. And it's August 27th now, so we're about 12 hours from being the end here. Because we do live in a cause and effect universe, don't we? So there's no CME events. I mean, maybe some little ones. But a K index of 6 or 7, wow, I would expect some kind of coronal hole or a CME, and we're not seeing much of anything. Huh.
Not even a solar wind?
Well, I mean, I'm looking for coronal holes, and
Right now, the K is at 3.
I'm not. I mean, there really aren't any coronal holes there, right? Um, the one of the best wavelengths to actually see coronal holes is 190, or sorry, 211, the purple one, and it looks like the corona is a little bit thin here, so yeah, maybe that's what's causing it. Now, what was the website that you mentioned, Bobby?
It's called solarham.net. I'll also check the chat about the more information about the sun.
Wow, look at that. Yeah, look at the K index. Wow. Yeah, so that was, well, 24 hours ago. But why? But why? Uh, yeah, I'm just wondering why. Surprise geomagnetic storm. A crack opened in Earth's magnetic field. Yeah, of course, there's always, some solar wind and whatnot, but sometimes there's more stuff than other times. So yeah, a little weird, a little strange. Um, X-ray flux. Well, this is just showing the past few hours, so that's not going to help us much. Actually, a really great site is for at least data is Ben Davidson's site. Trying to remember what that's called. He's got a specific one.
Kind of weird if it's not a solar wind or something's probably got to be a cosmic ray or something.
Yeah, I'm not sure. I mean, Tom is saying something in the chat about a crack opening in Earth's magnetic field. That's a little weird. Hey there, Tim. Nice to see you in the chat.
What's up, Tim?
Tim was on earlier doing a live stream. Haven't seen Tim in a while, so definitely wanted to get over there to see what was up with him. Sounds like everything is going well. Everything's well here too. Yeah. Except for this weird solar event, which I'm not quite sure what's going on there. What is well, let's just go over to let's go over to Ben's. Whoop, is that not it? It's is that a IOUS, I think. Is that it? No, what is it? Hold on, I'm gonna put you down. .org. From here, we can go to Space Weather News. Here we go. So this is just a lot of good, nice data all in one place. We can see, we can track the solar wind. Here's the wind speed, right? So it has been increasing, right? Increasing. Density has been decreasing, which means less stuff.
Night, Tim.
Temperature has gone up. Tim Tim just popped in really quick. All right, Tim, take care.
And Uncle Bill Duran says check out spaceweather.com.
Yeah, space weather. That's that's what I was thinking of. Spaceweather.com. Oh, weather. Bad typing day. Surprise geomagnetic storm. Last night, a crack opened in Earth's magnetic field. Solar wind poured into fuel a strong G3 class geomagnetic storm.
How can the geomag can just crack open causing disturbance?
I've got the same question, and you know, my quick answer to that is I have no idea because I don't know enough about this kind of stuff. Forecasters did not see this coming, huh?
Yeah.
Opening a crack. You know, I I don't know if I like that term or not. That's sort of a weird that's sort of a weird term to use. Um, a crack.
That is gotta be the most absurd thing that I ever have seen.
Yeah. Well,
I thought it was going to be that solar wind and stuff, but it was if it's not if the sun is not the planet, but the geomag is, man, that's kind of a bit crazy.
yeah. Well, as I said, we sort of rely on this idea of cause and effect, right? And we're seeing this this effect that doesn't seem to have a cause.
Check
Now,
out Uncle Bill's link as well.
okay, let's take a look here.
It's,
Cracks in Earth's magnetic shield. Oh man. To gush through and power stormy space weather.
oh, that's in 2003.
Yeah, well, information remains the same, I would think. It's just yeah, that's just when I assume that's when this was written. But okay, yeah, I'm gonna have to investigate this a little bit more because kind of interesting, kind of interesting. I mean, for sure, right? For sure, the wind speed has increased. Not anything insane, though, right? I mean, 550 kilometers per second. That's not really fast. I mean, it could go a lot more than that. Temperature is pretty high, right? It's kind of weird that it's plateaued, but it seems to coincide, right, with this weird event.
Uh,
The X-ray flux,
yeah,
which
I wish like Jules were here to tell us about why a crack instead of some interaction with the solar wind and stuff.
mm-hmm, looks
And
like
why it almost hurt the propagation and stuff.
yeah, interesting, interesting. So yeah, because there's like absolutely no solar activity at all, right? Just sort of a regular old humdrum sun, doing its thing. But yeah, to have a K index that high, that's and for pretty long, right? I mean, that lasted almost an entire day. So these things are updated only every 3 hours. So it's hard to know exactly what the details are here. But yeah, kind of cool, kind of cool. Cracks open for long periods can be Incorporated does a good job. Even so, auroras which light up to 100 million. It isn't really saying why it happens, though. Far-flung part, according to new observations, however, sometimes develop and in the Earth's magnetosphere and remain open for hours. Okay. Still not understanding exactly why that happens, though. Huh. Interesting. Does make for some pretty aurora, though, eh? Sweet. Gorgeous.
Yeah.
This is
I'm not even sure if Temperature Scope is very stoked about this. Surprise.
Who isn't stoked?
Temperature Scope is called the Space Weather Woman. You can find her on Twitter and on YouTube.
Yeah, yeah. Well, maybe she'll have something to say about it, but yeah, that's kind of unusual, I would say. Kind of unusual. All right, well, cool. You know, let's move on. So cheers to unusual events. Keeps us on our toes. I like it. I like it. So yeah, what I thought that we could do tonight is do another constellation of the day, constellation of the week, whatever you want to call it. So there's 88 constellations up in the sky, both northern and southern hemisphere. So let's get random.org to choose our constellation for us, and then we'll dive into it a little bit and see what constellation it is. We'll look at some of the stars in there, some of the objects that are part of the constellation, and follow our noses like we usually do here. So all right, here we go. Bam. Number 15. All right, so I've got the list. It's an alphabetical list of all the constellations, and as you can see, there's 88 lines there, so there's 88 constellations. We're going to go to number 15. Canis Minor. Canis Minor. Cool. So another northern constellation. I guess Canis Minor is actually one of those constellations that can be seen from pretty much north and south. I guess Canis Minor is a little bit more north than Canis Major. But let's take a look. Canis Minor. Pretty small constellation, gotta say. Pretty small, just more or less, right? 1 hour of right ascension and 10 degrees of declination. So just a little tiny guy, but does house one of the brightest stars in the sky. A Procyon. I'm not remembering which. Let's go over to brightest stars in the sky and see which one Procyon is. Looks like it's number 8. So yeah, definitely one of the top 10 brightest stars in the sky is Procyon. So very, very cool. Now this constellation, of course, is pretty near to Canis Major, which houses the brightest star, other than the sun, in the sky, which is Sirius. But Procyon is definitely, let's see if we can actually get a magnitude here. 10 brightest star. Well, let's see if this guy gives us the at least the visual magnitude here. Arcturus, Vega, Capella, Rigel, Procyon. So Procyon, I don't see any magnitude there at all. You would think that a list of bright stars would give their brightnesses, but it doesn't. So let's see. Oh, Wikipedia will, but let's see if this one does. Sirius. One. Canopus. Is this gonna? All right. You know what, guys? If you're gonna list the brightest stars in the sky, please remember to give us their magnitude. Okay. Now, see, Wikipedia is smart because it actually lists the sun as the brightest star in the sky, and that's absolutely true. It even gives a distance in light years. Pretty good. Pretty good. Anyway, Procyon is at least a visual magnitude or a V magnitude. Now, when I say visual magnitude, I don't necessarily mean V magnitude. V is a very specific thing, but it's sort of looking, yeah, maybe this is more like a visual or what they're calling the apparent magnitude. And that would be like a broadband magnitude. A V magnitude is actually corresponding to the Johnson V filter, which is sort of a narrow band filtered centered around like 5,500 angstroms or so. So I'm sort of thinking that this is probably what they say it is, being the apparent magnitude, which is very, very broad band. So it sort of spans the entire visual range. So if you collect all of that light, add it all up, that's what this magnitude is. So 0.34. So yeah, pretty bright. Yeah, nice bright star, easy to see, extremely easy to see, right between Canis Major, which is down here, and Gemini, which of course is up here. So definitely not a lot of stars to see, but I'm going to I'm going to stop sharing my screen and get back on here. Let's take a look at, wonder, is this, I'm going to Burnham's Celestial Handbook. Okay, this volume, which I think is volume 2, starts with Chameleon, which is MN. Oh, it should be in here, right? Canis. Oh, no. Chameleon starts with a CH. So I'm looking for volume 1. Oh. Huh, where did my Burnhams go? I only see one volume within reach, even within visual reach. Where's my other Burnham Celestial Handbooks? Not up here.
Man, you used to have those books in a certain place.
Almost like the calculator, just right there. But, I might have to, I'm looking on the bookshelf where they're supposed to be, and I'm not seeing them. I don't know where I put them.
Oh my gosh! What the deuce?
Mad scientist alert. Always dropping his stuff somewhere, losing things. Well, all right. We'll just go with the flow here and go back to Wikipedia and see what we've got.
I wonder if there's like an online edition of Burns.
Oh, I don't know, and I don't think so. I don't think, I'm pretty positive not. Let me go look in one place that I can't see from where I'm sitting. Hold on one sec.
Yay!
Ah, they were there all the time. Uh-oh. Uh-oh. Let's look at Canis Minor.
Blame the cats.
I'm going
The
to blame
cat
the
buried
cats.
it.
The cats did it. Yes, yes, yes. Absolutely. Let's see. Cassiopeia, Carina, Canis Major. Oh, Canis Major. Where's Canis Minor? Ah, here we go. All right. Oh, okay. Well, Burnham's does actually have quite a bit here. Again,
Yeah.
you know, Burnham's is really, really great because it's sort of for observers, and it's now actually really outdated, right? But I sort of use it as a beginning point, as sort of a stepping stone into more stuff. And usually, Burnham's does not disappoint at all. So here's what they show, um, a list of all the binary stars. And then this next list in the middle is a list of the variable stars that they were aware of, at least at the time, right? There's, as I said, you know, this information is actually really outdated now. There is so much more, just unbelievable amount more. But the cool thing is, as an observer, right? Um, you know, this is a pretty good start in terms of observing double stars, right? That's a nice, big, juicy list. You know, you could spend weeks or months um, just observing these guys. So very, very awesome, very awesome. In fact, they're saying, and I don't I don't know if I knew this or not, but they're actually saying that Procyon is a binary star, with a 40-year period. The primary star is bright, right? They're calling it first magnitude, but it's actually a little bit brighter than that. And its companion, they're saying, is like 13th magnitude. So interesting. Interesting. So yeah, you know, we should let's see if Wikipedia has anything interesting to say about Procyon. Let's see, I'm going to share my screen again. And I should check the chat. Make sure there's no mischief over there that I'm missing. Yeah, yeah, no, you know, I can't blame the cats for this one. So, well, I can blame the cats for lots of things. Let's see. So it always does that. So I'm going to click on a link called Procyon and just sort of see where this brings us. So Alpha Canis Minoris, brightest star in the constellation of Canis Minor. Appears to be a single star. But it has a faint white dwarf companion. Oh, so it's a white dwarf. So that's a lot like Sirius. Sirius also has a faint white dwarf companion as well. So very cool. Very cool. So the spectral type of Procyon itself, Procyon A, I guess is F5. So that's a little bit hotter than our sun. Our sun is a G2. So an F5 is a little bit earlier spectral type than that. So you can say it's a little bit hotter. Let's see. Okay, so here is the sort of an orbit of sorts, right? So here's Procyon A, and here's the orbit of Procyon B, and they give little dates and stuff. So I guess what 2016, 2028. So what it should be right about here, right now. Is it saying anything about its orbital parameters? Let's see. So Procyon B is actually magnitude 10.7. That's pretty bright. 40-year period. High eccentricity. So the average separation between them is 15 astronomical units. So yeah, wow, that's actually pretty close, right? So it looks like the closest it gets, right, which is here, which would be periapsis, is about 9 astronomical units, right? So from here to here is 9 times the distance between the Earth and the Sun, and between here and here is 21. So yeah, very cool, very cool. Pretty cool. That that it's does it give the actual angular distance between these things? I mean, how far away they appear to us in terms of arc seconds? We could work this out. If we know how far away these guys are from us, we could work out what the separation is. Not seeing anything about that here, which sort of don't like that. It'd be nice to know how far apart these guys are. Burnham's says 3.9 arc seconds, but as I said, Burnham's is a little dated, so I'm not going to necessarily trust that. Oh, here we go. Okay, so semi-major axis is 4.3 arc seconds. So that the semi-major axis is from here all the way over to here, right? So this distance here is 4.3 arc seconds. So if it's over here now, that's not quite as far away as it's going to get, but yeah, just guessing, I'm thinking it's probably like 3 arc seconds away or something like that. So yeah, pretty hard to see with most scopes. Seeing is going to be like an arc second in size, so you're going to have a big bright blob like that, and then to be able to try to see that, that's going to be a little bit tough with sort of a normal scope, but pretty cool. I don't think I knew that about Procyon, that 1, it was a binary star, and 2, its companion is a white dwarf. Very cool. QZ. Let's look at the reference. So you start diving into the rabbit hole here, and oh, okay. Procyon B, outside the iron box. All right, we're going to have to look at this. Sorry. Follow our noses here. Let's see where it goes. We can find out a little bit more about this white dwarf star. Procyon B. They put stringent constraints on the fundamental physics of stellar degeneracy. Degeneracy is a sort of a state of matter. White dwarfs are so-called electron degenerate stars, in that all the atoms are packed as close as they can possibly be, but the electrons are actually holding them all up, right? So you know, like charges repel, right? So the electron shells of atoms and molecules and all that sort of keep them apart. And in normal matter, there's actually huge gaps between molecules and atoms. But because these objects are so compressed, they actually compress down, and all that space between the atoms and molecules gets eliminated, right? So there's no space. So translating that, if you were to take our sun, right, and squeeze it down to the electron degenerate state, it would be about the size of the Earth. And that's actually what the size of white dwarf is. It has about the mass of the sun, but it's the size of the Earth. So extremely dense. So anyway, that's what degeneracy is. There's also a second kind of degeneracy called neutron degeneracy. And that's where the electron shells can't actually hold up that, and the electrons get squeezed into the nuclei of atoms. They actually combine with the protons to form neutrons, and you get a neutron star. And that's where the space between the nuclei of atoms and the electron shells vanish. And as you may know, there's a lot of space in between that. So a star the mass of our sun, or maybe 2 or 3 times the mass of our sun, can actually be squeezed into an object that is just a few kilometers in diameter, and that's a neutron star. Extremely dense matter. Let's see. So yeah, it sort of looks like they've been looking at this guy with spectroscopy, and they're finding carbon and magnesium and numerous iron features. And so it's called a DQZ white dwarf instead. Very cool. So, and as you can see, it has a radius of 1% of the radius of our sun, which is about the size of the Earth. Don't remember exactly what the ratio is between the size of the sun and the size of the Earth, but I think 1 to 100, I think that's pretty close. So very cool. Procyon B. Procyon B. I'm not going to spend too much time here on this. There's a list of observations that they made. It was all spectral observations. So yeah, here's sort of a typical spectrum. Kind of cool. So these are sort of going from, far infrared, where we really can't see much, right? That looks like that's around like 8,500 angstroms, which is really, really, really in the red, way over into the ultraviolet here. You see some nice absorption line there. That's probably a hydrogen band of some sort, probably. But you can see all these other absorption features here. All these wiggles, at least most of these wiggles, have some kind of meaning, right? They're showing off certain things, certain chemicals. I guess they're finding. Let's see, what are they doing here? I'd like to see a spectrum where they actually identify. Okay, so here's carbon 1, right? Just regular old carbon in the ultraviolet, right? 1930 angstroms. That's quite in the ultraviolet. So, yeah, I think they're observing this with a space-based observatory. I think I noticed them looking at it with STIS, which I don't remember what STS stands for. Let's see if we can find that out. STIS. They're going to say the Space Telescope Imaging Spectrograph. I think, yeah, that's actually part of HST. Yeah. So very cool. Let's see. So that's there. They've identified carbon, and yeah, I would say probably not very much, right? But pretty clear, right? There's some feature there, and they've identified that as carbon. Okay, so they're seeing actually the magnesium 2 lines and magnesium lines as well. So that's pretty cool. Let's see, that's the solid line is their observation of Procyon B. And they have a bunch of models to see what's going on. Okay, that's kind of cool. Let's see, what else they got here? So, yeah, to see carbon and magnesium and heavier elements inside of a white dwarf, that's pretty unusual. So something interesting is going on there. Don't know what. Let's see. Yeah. Oh wow, that's flying way over my head. I'm not even going to try that. Looks like they're trying to fit it, to different models, right? They have different parameters here, right? They're changing the temperature. Looks like they're changing the radii too a little bit, and whatever this F number is, I don't quite know what that is. Okay, it's pretty cool though. Amazing amount of work goes into this kind of stuff. Okay, so here they actually have some numbers for us. So it's looking like Procyon B has a mass of about 0.6 solar masses. So a little bit more than half the solar mass. You can sort of see how that compares to other white dwarfs in binary systems, including Sirius B. So this is actually pretty cool. Cool as in temperature, as far as a white dwarf goes. That's a pretty cold white dwarf. 7,700 degrees Kelvin. That's a pretty cool white dwarf. As you can see, Sirius B is pretty hot, and 40 Eridanus B is actually pretty warm too. I think this is this parallax? I think that's what pi is in this case. Sort of pretty standard size. I'm not going to get into that. That's looking at errors and things. That's a complicated subject. So let's see. Unique abilities of HST, right? Very cool. So carbon, helium-rich atmosphere. So maybe that's a helium line. Not quite sure. Okay, so yeah, maybe it's a proximity issue. Maybe there's a little bit of mass transfer going on between Procyon A and Procyon B. Oh yeah, they're actually talking about an accretion rate here. So, not a lot of stuff, but maybe measurable, right? An interesting and important object deserving continued attention. But yeah, always want to try to make those errors as small as we possibly can. Yeah, cool. Very cool. I sort of laugh because these points are just all over the place, and look at the error bars. They're just, big. Lots more work has to be done. If anybody wants to get into astronomy, there is a lot of work to be done. You just, the only real obstacle to effective astronomical research is, you've got to have the instrumentation, and you've got to be able to feed yourself, pay the bills, right? So that's the only obstacle. You don't really have to be, education will happen, right? So cool. All right. Well, there's something interesting about Procyon for sure. Let's go back. Wow. Now, where were we? We were in Canis Minor, right? Let's see what else is going on here. What else does Burnham's talk about? Anything else? I mean, lots of binary stars. Lots of binary stars. Let's see what Burnham's actually says about Procyon B's orbit. Do they actually give? Let's see what Burnham said about the orbit. Anything? Companion? It's known for over a century. I'm just really scanning this really quick. So Burnham said that the semi-major axis is 4.55 arc seconds, and I think that was pretty close to what this says too, right? Yeah. So not too bad. Pretty up to date, I guess, as far as that goes. Let's look at variable stars. Always variable stars, and there's probably a heck of a lot more now, with Gaia and sort of the modern era. We're finding out all kinds of other stuff. So a few variable stars. Does Wikipedia say anything about any interesting variable stars here? So yeah, they talk about Procyon, of course. Delta, HD 66141. Um, yeah, they're just talking about, okay, yeah, here they're talking about a couple of the variable stars. So that's a big magnitude range. Kind of cool. And it's a Myra variable, which I think I think I think Myra is a single star that actually changes size, right? So it gets really small and really big, and then really small, really really big. I mean, it physically changes its size. So yeah, that's quite a change in brightness over the course of a year or so. Kind of interesting. I should check the chat really quick, make sure I'm not missing anything too much. Yeah, I totally agree that I'd like to see some hard data on those cracks. So it is electric for sure, But yeah, I'd like to see a little bit more about that. Okay, so looks like there are a couple deep sky objects here. NGC. Now Burnham's doesn't list any, right? There's no listing of deep sky objects inside of Canis Minor. So these have got to be pretty faint objects. And in fact, this first one, right, I'm seeing NGC 2459 is a group of 5 13th and 4 14th magnitude stars. So we could actually go on to Gaia and see if they're, moving together and all that. But it sort of looks like they're just coincidentally lined up. And it looks like the same thing with NGC 2394. But NGC 2508, cool. Let's see. Always like to see like pairs of galaxies. I love galaxies, so let's go ahead. Which one of these should we do? Let's get 2 for the price of 1 here. Ooh, nothing there. Let's see if HST has looked at that. Now the chances of this are extremely low, but let's take a look anyway. Was it 2402? NGC 2402. All images, all spectra, and everything else. Bummer. Okay. Let's go over to Sinbad and take a look over there. I just want to get a picture of this silly looking thing. Binary pair. NGC 2402. Is that what it was? Yeah. 2402. Sinbad will have something about it. Not much. Pretty faint in the visible. A lot brighter in the infrared. Looks like elliptical galaxy, and yeah, there is another guy right next to him. A couple of different names identified by Gaia. No distance measurements, but they've got some velocity measurements. Look at that, only 10 references. Well, we should definitely look at that then. Let's see if there's anything specific. Anything specific about 2402, or are these just all catalogs? Well, there's a 2403. I wonder if that's the guy right next door. Could be. The NGC objects are listed in order of right ascension, which moves to the east. So I wouldn't be surprised that this is 2403. Should we we can confirm that. Let's just look for 2403 and see if it presents us with the companion to 2402. Bet you it does. Oh, it's not. Interesting. Okay, so 2403 is something completely different, I think. I mean, that doesn't look like that other guy. Let's back out a little bit and see. 2403 is pretty, but it may not even be in the same constellation. No, it's not. Definitely not. All right, well, and then just forget about that. We are not going to look at that because it's not in Canis Minor. Did you see 2402? Kind of interesting, though, that they have a reference to 2403, right? That's a little weird. A little weird. Well, let's take a look at the picture anyway here. Let's see if the Sloan Digital Sky Survey has maybe a little more interesting picture. I don't know if they would pop up here or not. Or does it look like it's going to? They may not have imaged it, but we'll just stick with the Digital Sky Survey instead. So nothing too exciting here. Nice pair of elliptical galaxies. Pretty much everything else I see is a star, a foreground star. Kind of amazing, to think that everything else in this shot is part of our galaxy, except for those two little guys right there. Pretty amazing. Obviously, some kind of weird either optical effect or some kind of processing flaw, who knows what. So yeah, a pretty sad looking elliptical galaxy that nobody cares about. The kitty in the lap. Happiness is a kitty in the lap. So let's see, anything else interesting here? Not really. Not a very well studied object at all. Oh, that's too bad. I think somebody should. Spiral Galaxy thought to be approximately 245 million light years distant, 55,000 light years in diameter. That's about half the diameter of our galaxy. All right, well, there's Canis Minor in a nutshell. It's small constellation for sure. Let's see, I'm going to stop sharing because I think it's about time to end this for now. I've got a kitty in the lap here rubbing against the microphone. Hi. Is it time to go? Are they calling? All right. Kitty Patrol is definitely saying it is time to go. All right, you guys. I guess I'm going to get out of here for now. So have a great evening, a great day, and more astronomy. There is so much astronomy. We will never ever run out of things to talk about in terms. Now I'm getting chewed on. Great. Thanks so much for that. I'm getting chewed on. There is so much to talk about in terms of astronomy. Look, this live stream will never ever end. There's thousands and thousands and thousands of things to talk about, and they're all unique in their own way, right? And they're all amazing. And when you think about, we're looking at these fuzzy little blobs, right? These fuzzy little blobs, nobody even cares about. right? Nobody's even looked at them, right? They've taken a picture and it's like, psh, push into a corner, right? But if you think about the fact that these things are made of billions of stars, right? That all are unique, right? Now they may fall into families, they may have similar um, characteristics and all that, but they're as unique as you and I, right? So, we all have eyes and ears and chins and necks and hands and everything else, but, my hands are completely different than yours. And so it is with stars, so it is with galaxies. And so, we're looking at these fuzzy little blobs that nobody cares about. And there's billions and billions and trillions of stars, planets. I mean, who knows what's going on? Civilizations, the whole thing. It's all going on. The drama of the universe is taking place as we speak, and we'll never know. We'll never know a thing about any of that at all. But I think it's really, really amazing, and I stand in awe and bow bow to the incredible universe uh, for which we are a part. We're not separated from that. We are intimately involved. If we can see those objects, then we are actually within their electromagnetic sphere, right? Um, and when we see those things, we're touching them. It's just a different way of touching them, but we are in physical contact with those objects. Hundreds of millions of light years away, some of them billions of light years away. And I just think that's incredible. I think that's amazing. All right. Well, enough of all that amazement. I'm going to get out of here for now. So take care, everybody. Peace, cheers. I will see you on the spin a little less than 23 hours from now. Take care, everybody. Bye.